Hi, I'm Peter Hill and I'm presenting another episode of Quantum Physicist in the Australian Bush, where the basic message is that quantum is coming. Now, I've worked on some explanations, worked on trying to deconstruct some of the misconceptions which are driving things. I've also been building basic quantum physics classroom experiments. That's where you put something together, and hitherto it's been too complicated, but you just present it in the classroom and you can actually see quantum mechanics at work. And as part of that, it's been an education for myself. I've gone into electronics and realized that my electronics is 30 years out of date, and I've really learnt a lot about that. I've had to do things, and then I've looked at the mobile phone for recording this, which is better than what I had before, and also mobile phone as a device to assist students in the classroom. So what's going to follow is 10 minutes of just me exploring apps on the mobile phone. Now, the critical app, I suppose, I found is a few physics apps, but also a few physics teaching apps, as you'll see, but also a screen recording app. So you can, what you'll see is the phone as I have, and I think this is a real game changer. The fact that students can measure acceleration in their hand, magnetic field in their hand, turn their mobile phone into a sophisticated strobe light analyzer, all this sort of things. I think everyone knows. It's just I'll walk you through downloading the apps onto your Android and activating. You'll see me do all of that, and at the end of it, you'll be up to where I'm at, and it's all part of learning your way forward. So as I'm looking at building advanced, intelligent wireless speakers, there are certain things that I don't have to build because we have the mobile phone to be able to do that sort of thing. So watch as I present the next section. Thanks for looking. I'll start off and trying to keep up. The first screen was a compass which you can download, a spirit leveler. It needs to be calibrated. Quickly do that. And we see it as I just download this app as a spirit leveler, and it allows you to measure tilt. So my overall view is that this would be very good in the classroom for ramps, to get angles for ramps. So if you set the angle of a ramp, it actually friction. This is putting up into the next level, not just the spirit level, but the actual greater range level, and it tells you the angle at which it's sloping down 45 degrees or what as you go down. Now this is the recorder, which I've put in to record my screen. I've just recorded to see whether that has recorded the magnetic Now this is the recorder, which I've put in to record my screen. I've just recorded to see whether that has recorded the magnetic compass, and looking at the various images there, and you can actually put them together. However, that's limited, so you can actually compress them. It takes a little bit of fiddling on the mobile phone, but it's perhaps best to download it completely to your computer. So that's a magnetic compass which I've downloaded, and you have to pick it across and download it into your video editing software. But this is all my mobile phone screen, and I just want to find out where that is. So essentially there's a sequence where you open up the file, you search for the file, you write the file name, you search for the file, and you can find it. Now you search for the file and you can find it. Now I want to see of greater use. Sensor kinetics is the first one I'll look at. So you type that into Google Play, and you can see I'm typing a little bit slowly here. You then install it, hit the install button. Now there are a few things where it's all looked good, but when it's installed it wanted you to charge your money, and then it's for me a bit of a panic to uninstall it before it charges you money in 14 days time. This is another physics toolbox, probably a superior sensor suite. overall. However, it has, as it says, contains ads. So here's Sensor Kinetics opened up, so it's downloaded very quickly, and it's good. You've got the accelerometer there, updating relatively quickly at 20 times a second, and you can demonstrate it. That's the magnetic sensor demo. It's the demo version, but you can also in all of these pick up different things. You could see me there just going out when it didn't miss graphical version, which I didn't press next. And now these are derived 3D sensors from the actual sensor. It actually works out what it is. Now it's interesting that you've got the X, Y, Z gravity, and we also know that it should be 9.8 meters per second. And if you add those up, x plus y plus z is greater, but it's actually the square root of x squared plus y squared plus z squared. Now this is the acceleration, linear acceleration. Look at it, so that's a good thing to look at, and you can print it out. My mobile phone's not the greatest, so it doesn't have a pressure humidity sensor. And then this is g-force versus time. So the g-force versus time. So the g-force is 9.8 divided its own force by 9.8. Now you see that if you were to add those, the red, green, and blue up, they would. And this is me just tilting the phone. You would get much greater, but it's the cube root of it. This is just a more total acceleration. You can see it's operating a lot more fast, and it's removed the acceleration due to gravity, and you can see my hand moving it left, right, and center as we go across here. And if you press the red button, it takes it down to a file which you can print out if you wanted to. Just a bit scared about doing that. These are, if you press the row of lines up to the left, you will get these options that you can look at. Now the GPS was a bit disappointing in that it found the satellites but nothing else. There's the ruler option, which seems a bit silly. You can only measure between your two fingers, but if you move your fingers away, you can actually measure a device. So you could task to your mobile phone and measure it. That sounds stupid. You can see my fingers moving back, so that's quite good, and it gives you 10 micron accuracy. So that's incredible accuracy if you can get it to go forward on that. There's looking at a few other things that you've got there. Compass, GPS, looking at the total g-force here. So this is the acceleration is 9.8 meters per second. Then going back to magnetic field. Now I'm going to take this over and measure the magnetic field around the place, but I have some magnetic field devices I'll talk about soon. Now I'm taking it over to my Einstein to Haas experiment, and this rotates the magnetic field 7 times a second back and forward. 100. So it's rocking the magnetic field back and forward, rocking the electrons back and forward, which actually rocks the pendulum. So as I take it away, you can see it measuring the magnetic field as I move further away from it. That oscillation is the solenoid I've developed. Now looking down here, looking at the other things I can look at. I can't quite remember which I selected. Going down here, looking at the sound analyzers. Now I've given it permission, but it just doesn't quite get through. So there's sound oscilloscope. You can imagine all the science lessons you can teach with this, but no, it doesn't quite work on that. So perhaps the school should have a couple of cheap mobile phones with the apps already available in it. So your class set of mobile phones would be the thing that are so cheap, especially when people throw these phones out. What I can do is this enter data entry. Enter data entry. Know at the start that the X and the Y do just simply Y. To see what it, imagine this is a very worthwhile thing to actually ready to go out. I'm sure you can just executed or screen saver. This is a color analyzer, which is actually rather good. So you can actually say go up to your cubby house or your wall, you mix something, and it actually gives you the exact I suppose hexadecimal unit of the actual colour and what it sees in there. So that's also very useful. So I use that for when I'm building things. You can see sort of the messy room I'm in. And let's look at what I'm going to pick up next. So inclinometer. So this is in your plane. So it's when I'm building things. You can see sort of the messy room I'm in. And let's look at what I'm going to pick up next. So inclinometer. So this is in your plane, so to speak. And I suppose this is just basically good for teaching pitch, roll, and azimuth, which is your directions where it's pointed. So the azimuth, I think that means height from Arabic. And that's about all for the moment. Well, I hope you found that video tutorial helpful. It's not perfect. However, I find that it's better to produce a large number of things and see how they work, because some things that you don't think are good have a large number of hits, and especially the ones where you see the phone and you can work through and stop the video. So the video is a new form of teaching. It's also I'm also process oriented in terms of I'm not interested in producing the final perfect product. I'm interested in producing sufficient products to give me sufficient feedback to improve each time. As I've said, quantum is coming, and it's coming by process, and I'm working away a little bit at a time. A few experiments and a few programs, a few lessons, gradually improving 10% at a time, and we'll get there. You keep up your efforts, mate.